All right, welcome everyone. Thanks for letting me join the EDA Summit here. My name's Ken Lane. I'm the Chief Evangelist for Postman, and I'm going to talk to you about the API lifecycle and mapping out the API lifecycle. This is what I do for a living is I pay attention to the API lifecycle, and for the last decade, I've been studying how the enterprise organizations think about their APIs when it comes to their websites, their mobile, and other types of device applications. Joined Postman about 2 years ago, but I've been pretty much spending the last decade talking to enterprise organizations about how they do APIs, and I'm just bringing this knowledge to Postman. And one of the things that I focus on as part of my career is the API lifecycle and how specifications specifically impact the API lifecycle. So think Swagger, OpenAPI, most recently AsyncAPI, but we're going to talk about all of that here shortly. So quick plug, this is why I'm able to be here is my company Postman allows me to talk to different groups and kind of share stories about what we're working on. Postman's a collaborative API development platform, but today's talk is about the wider API lifecycle and space, which the Postman platform is great for. But what we're going to talk about is zooms out and kind of hopefully will help show you the bigger picture when it comes to how APIs work. So let's kind of set the stage for how we got here. Back in 1995, 2000, as the web is taking off, APIs they're nothing new. They've been around since the 60s as the internet was taking hold. But really around this time, as the web was taking off, a handful of providers, namely eBay, Salesforce, and Amazon, started using the web in a little different way and providing APIs or application programming interfaces that would help make data and content and media and other digital resources available. And fast forward that a couple of years, you've got Flickr, Google Maps, you've got Twitter, Facebook, all these social platforms realizing the potential of using APIs to deliver content to partners and affiliates and other things and making things more social. But by 2010, we had the mobile phone, the iPhone and Android specifically introduced, really increasing the types of APIs that were needed, Twilio, Instagram, Foursquare. And then, fast forward that to 2015, everyone's realizing that APIs are how you deliver data, content, media to web, mobile, and device applications, connecting devices, cars, and other things to the web. And so here in 2021, there's many different types of APIs doing many different things, handling different loads. While there's one type of API that's called REST, which kind of dominates much of the conversation when we talk about APIs, there's a lot of different APIs out there. And we're going to kind of walk through that landscape a little bit so that you can better understand what it looks like. So as the number of APIs have grown and we've added on more websites, we've added on more mobile applications, we're creating more and more APIs across all of our teams and organizations. And the challenge is they're not always the easiest to find. These are not always well done, well documented, and available for developers to put to use. Now, there are plenty that are, but as the number increases, it's getting harder and harder to discover, see, understand. The APIs are out there. And I'm talking web or REST APIs. I tend to call them web APIs, and event-driven APIs as well. And these may be using HTTP or HTTP2, and but we have them all across the enterprise organization, driving many different applications, and they're just getting more and more difficult to see and make sure that they're all working in concert. And so what I wanted to share with you today was a little bit about how, from my vantage point in the industry, how different enterprise organizations are dealing with this and making sense of it all. So to help help make this a little bit more tangible and meaningful, I'm going to use the Slack API as an example. So if you're not familiar with Slack, it's a messaging platform, pretty popular in developer circles, and happens to have an API behind it, and they use the API to create bots and other types of automation and integration, and it's a pretty robust community. But Slack has two different types of APIs. They've got a web API, and then they've got a event-driven API. And so when it comes to how that API is used by consumers, is evolved by Slack, and then how it's built on, integrated with, is it's a lot of work to do that. And Slack has employed a couple different ways to help them manage that life cycle in a consistent way and map out and understand the entire surface of their APIs for their organization. So the first cornerstone of how Slack is getting a handle on not just their APIs and being able to map them out and see them, but the life cycle around those APIs is using the OpenAPI specification. So many folks might know this as Swagger. Swagger is actually the last version, which was 2.0. And then once it got put into the Linux Foundation, it became 3.0. And it's actually now at 3.1. And so on the right-hand side there, you'll see a snippet from Slack's web API description. This is a machine readable. This happens to be YAML, but it could be just as easily be JSON. And it provides a way of describing the surface area of web, RESTful, or HTTP 1.1 APIs. This is the most common type of API that you'll come across today, and OpenAPI allows us to describe all the technical details of how it works, as well as webhooks, which is kind of the 101 or the introductory level of event-driven APIs. You have web APIs that get a lot of traffic, get a lot of chatter, a lot of consumption, people pulling and hitting it. You may launch a webhook to then say, hey, slow down, don't ping us. When we've got something new for a specific event you need, we'll send it to you. And you can map those out and describe those in OpenAPI with 3.1. You could do it before, but 3.1 introduced some pretty significant changes when it comes to the webhooks and allows you to track it a little bit more. So OpenAPI is what you use to describe the request structure as well as the response structure for web APIs, what will be sent and what will be received. And how you describe that payload, those schemas that get either posted or get received as part of a response, is the schema. And OpenAPI uses another specification called JSON Schema to do this. And JSON Schema we'll talk about on its own in just a little bit, but it's how you describe the payload of each API. So if you're making a call to the Facebook API to post something to Facebook, it's described as JSON, and JSON Schema will allow you to map that out and understand it in a machine readable way. Now, along the way, event-driven APIs are nothing new, but they've really increased in numbers in the last 5 years. You've got Kafka, you got NATS, WebSockets. When it comes to blockchain and financial, is pretty ubiquitous. And so around 2016, 17, a while after OpenAPI got going, AsyncAPI launched, and it is a sister specification to OpenAPI, uses very much the same format, but it's used to describe not just your HTTP 1.1 APIs. It potentially could be used to describe HTTP 2, HTTP 3, as well as TCP APIs or MQTT, AMQP, pick your protocol. And so like OpenAPI, it's used to describe the surface area, but instead of request and response, you have event-driven APIs. So you're going to have channels or topics that you can define, and then you can describe the messages that get passed back and forth. And then again, those payloads, those messages are described using JSON schema. So you can use JSON schema to describe what gets published or subscribed when it comes to an API, allowing you to map out and describe what your different types of APIs is going to look like. I think there's 15 or so bindings to different protocols. So OpenAPI is very much a single protocol specification. Async API has a protocol property and lets you choose from multiple protocols, making it a little bit more flexible in what you can do, but they work together. They're sister specifications that work in concert. So now just let's take a look at JSON schema all on its own. So JSON schema is a open source specification for annotating and validating JSON objects. Now, I purposely put the JSON example for the Slack API in YAML because it's you can use it in JSON or YAML, but the name is JSON schema, so people tend to think it's limited just to JSON, but you can use either format depending on what you prefer working in. But you can use it to model your different objects that are being passed back and forth, published and subscribed. And it's what becomes the core of your schema registry. All of the different objects that get published and subscribed or sent as part of requests and responses can be stored in your schema registry as JSON schema, allowing you to show what potentially each object and provide examples of those objects for discovery and for use in other APIs. Now, one thing I wanted to note here is I didn't mention when on the async, I'll go back a slide, is the that you can just, this is the Slack events API. This is not the web API. So it's very different, being used for different purposes. But it's using the same JSON schema objects to get the job done. And so really, that's why all three of these specifications work in concert and are so important, is that they work together. There are three separate specs. The OpenAPI is in the Linux Foundation under the OpenAPI initiative. And then Async API just actually joined the Linux Foundation under its own organization. So both of these specs are part of the Linux Foundation, open source, and available for the community to get involved in and evolve. Both of these use JSON schema. JSON schema is a community open source project. It doesn't have a foundation, but it's currently in talks with the Linux Foundation to also be added. So these three specifications are very much the cornerstone of how APIs are being defined, being mapped out, and being used across all of the web, mobile, desktop, and device applications that we're building on top of APIs. But the JSON schema portion of this that is central to OpenAPI and Async API is how we validate everything. It's how we describe the payloads for both, for all the types of APIs that we're describing with OpenAPI and Async API. And it allows us to automate the validation of those objects in transit. So when we're passing an object to a web API or receiving it from a web API, we can validate it with the JSON schema that it is secure and compliant request and response. We can also do that with any of our TCP or event-driven APIs. Is we can validate anything that's being published or subscribed in route and make sure that it's compliant and actually fits with what's expected when you publish or subscribe to these APIs. So you really use these, JSON schema is central for you to validate your APIs, but just to kind of show the scope of these and how important this validation is. You're validating your API in the center there, but OpenAPI validates itself using JSON schema. Async API validates itself using JSON schema. So there is a JSON schema for the OpenAPI specification, and there is a JSON schema for the Async API specification. That is how we validate API calls, but also the specifications we use to describe those APIs, just to get really geeky and meta there on you. So JSON schema, it plays this really central role. And there's actually JSON schema to validate JSON schema, just to further blow your mind and go there. So it just really can't emphasize enough how key it is for us to be, understanding the relationship between these specs, being aware of each individual spec, but understanding the relationship. Because not many people are aware that when they're working on OpenAPI, that bottom portion is JSON schema. Async API team mentions that a significant portion of their support is actually JSON schema support, because people don't realize that they're actually working with JSON schema. And so that just really shows the role of JSON schema, but the relationship here when it comes to mapping and understanding the API landscape. So why are we doing this? Why does it matter to have these maps of our individual APIs, but of all of our APIs across our organization? Well, there's many reasons, but one of the most visible and area, pain points that most organizations encounter is documentation. Being able to provide current, up-to-date documentation that actually describes the entire surface area of an API. So when consumers are going to put it to work, whether it's an internal API, a partner API, or a public API, that there's a reference that describes everything that it does. There's whole teams at groups that manage this. So it's not an easy task to do. And it's something that Swagger, OpenAPI, and Async API have done a lot to simplify. All you have to maintain is your OpenAPI, Async API, and JSON schema, and your documentation comes for free. There's plenty of commercial services, Postman included, that will take your OpenAPI and async and publish documentation. There's plenty of open source tooling, Redoc, Swagger UI, others that will take your OpenAPI and publish it. So it is, it's the most visible and discoverable part of how you map out APIs, make sense of them in a way that many people can work around, and understand. So documentation is really that visible piece for us that allows us to then be able to see the API. Actually, I mean, some of us really like working with OpenAPI and Async, and you can see it there. It's the scaffolding, it's the bones of your API. But the documentation is what it's like the sheetrock on the walls of your house. It's what people see. It's what you look at every day. It's what makes it more tangible and real. The other aspect of an open API definition is an async and JSON schema is it allows you to make the landscape across all of your APIs much more observable. So most business people see the user interface. They see the end result application of the API. So they see the mobile interface. You see Facebook on your phone, you see Facebook on the web. You don't see Facebook, the API. But because of monitoring tools, because of different testing, monitoring, security, observability tools that exist for APIs, you can give it that open API, an async API, and JSON schema, and it can monitor those APIs and then publish and provide a more tangible visible view of what's going on when it comes to actually your API operations. Kind of, pulling back the curtain a little bit, making it so that you can see what's going on. You can see each API as your documentation, or you can see them as a monitoring, any sort of charts, graphs that show its usage, how much usage it's getting, whether it's meeting those validation expectations, those assertions that are being made using JSON schema before. So we can be using JSON schema to define, see, and understand each individual API, render it visually on a dashboard, making it much more visible. So when we have hundreds or thousands of APIs across an organization, you can see it as documentation. You can see it as monitoring dashboards. You can understand whether it's healthy or not healthy, and how things are working beneath the scenes. So all of this really goes a long ways to making it so you can see your infrastructure and understand what's going on across your teams, across the API lifecycle. And again, this is a very Postman platform centric slide to show you how you manage the lifecycle. But OpenAPI, Async API, and JSON Schema are not unique to our platform. Every API service provider out there is using these specifications to describe and allow you to use their service or tool as part of your operations. So if you want to design your API, there's plenty of API designers, but this shows kind of a cross section of the life cycle. The bottom slide is very much how you define your different APIs. The next one is very much how you manage that life cycle, how you monitor, how you test, how you organize your schema registries, and how you publish documentation and then orchestrate using all of your APIs. And then, of course, you have your open APIs and other artifacts organized within different workspaces. Think GitHub repos, because workspaces and GitHub repos can be synced together. And it really allows for the your APIs to be worked on by different team members. There's a feedback loop that's present. So think GitHub issues, but more comments and discussions and around each API as it's being defined, iterated upon, or actually used in production. So you can actually be having a conversation across teams when it comes to how that API is designed, developed, deployed, and then ultimately deprecated. At what point does it get shut down? So version control, that's why you use these machine readable artifacts, is you can apply semantic versioning to them. So each of those open API definitions, async APIs, and JSON collections can all have a semantic version assigned. So version 1, version 1.1, when we iterate upon that with a minor update. But if we do any breaking changes, we have to then update a major. So go from version 1 to version 2. And we apply that to the open API. We apply that to the async and JSON schema. So we have a record of every version of our software, which helps when it comes to testing, documenting, doing all those things that I just talked about as you're building these APIs. But think of what you can do when you have this map of your API landscape available across all of your APIs over all of the time. So you basically have a record of every change that's been made. Hopefully you've got the conversation in the comment thread there. So you have the story of what went into the design and development of each API, and what's the story and narrative as it was evolved in production. And so you have that, and it allows you to make better decisions moving forward. If you can see your APIs, if you can map them out, if you can discover them, see them with documentation, and understand their health when it comes to monitoring and running tests and performance and security tests, you're going to make better decisions down the road when it comes to the next iteration of your operations. It's going to allow you to move forward faster in many different ways. And so it's just a look at how these API specifications allow you to map out an individual API. We talked about the Slack API. It allows you to do that with any API, all of your APIs across your operations, and then it provides you with that scaffolding and framework to understand change, make sense of how we got here, which then allows you to do a little bit more planning for the future. And so hopefully that gives you a little look into these open specifications. I'm guessing you probably have a little bit of experience maybe with OpenAPI or Swagger, but when it comes to event-driven, really Async API is definitely what you should be looking at, and the tooling, the testing, mocking, and other tooling that's emerged around that. So it really hopefully gives you a nice look at the landscape of what's going on, how companies are mapping out their API landscapes, and how they're making sense of it as it evolves. Because that's really the hardest part, is being able to visualize and see and understand all of this. And with that said, I'll just say thank you and some parting words. If you want to find me on the web, you can ping me at Postman. We're Get Postman. But also you can just find me as Ken Lane. I mean, pretty easy to find. But if you're not familiar with Postman, I definitely recommend coming down. You can download it or you can run it on the web. But I'm pretty easy to find. I'm very visible as a chief evangelist, and I'm happy to answer questions, talk about any of these specifications. I work with the OpenAPI, Async API, and JSON Schema folks, and their communities to help evolve each of the specs, and more than happy to point you to what you need to know to actually get things going. So appreciate everyone's time today, and hope you have a rest of a good EDA Summit, and we'll see you next time. Thanks.